Now let us see the time spent at the harbor. Okay, so it is 55 for the first ship. Why? Because it is for the first ship it is arriving and at t equal to 20, but as soon as it is arriving it is starting unloading. So the time taken for the unloading is the time it has to wait at the harbor. So time in the harbor in this case is given by 55 only for the first ship. Now for the second ship, what is happening? The second ship is arriving at the time t equals to 50. Okay, but it has to wait for some time, and that is for 25 minutes it has to wait. So it is starting its service at t equal to 75. Okay, then it is taking the time to unload is 45 minutes. Okay, so t is equals to 75 plus 45, so 120 minutes total. Okay, so 120 minutes it is taking starting from its starting point. So 75 plus here 45 minutes, so 120. Now from this 120, as it has arrived at t equals to 50, so from 120 if I subtract this 50, that is the time spent by the ship 2 in the harbor, because it is arriving at t equals to 50. Before that it was not there in the harbor, so we should not calculate that much of time. So from t equals to 50 should be subtracted from what? From the starting of the service time and the time it takes for unloading, that is 45 minutes. So total of 75 plus 45. So from 120 right forward, if I just calculate, I just subtract this 50, then what you get? You get 70 minutes, and that is the net time which ship 2 spends in the harbor. Time in harbor, okay, for 70. Similarly for ship 3, ship 4 and ship 5, these are the calculations which are coming. Okay, now so dock idle time is now what? That is for the harbor part of the management. What is dock idle time? At the very beginning 20 minutes was the idle time, and then throughout for ship 2, ship 3 there was no idle time, just then a ship 4 was a bit late in arriving. Okay, and it arrived at t equal to 185, but ship 3 has unloaded in t equals to 180, so 5-minute gap. So again the dock time of idle time is 5, so total 25 minutes idle time for the dock. Okay, for the time in harbor, that is time spent in harbor for each ship. Okay, if I try to find out the average, you can just see 89 minutes is the average timing. Okay, so in figure 5.9, as I already said, we are summarizing the waiting and the unloading times for each of the figure 5.9 we already used before for each of the 5 hypothetical ship arrivals, and this 5.14 table is giving what? The different results of the entire simulation of the 5 hypothetical ships. Okay, note that total waiting time spent by all the 5 ships before unloading is 130 minutes. Okay, this waiting time represents the cost. This 130 minutes total timing. Unloading time, not this one, my mistake, 130, this one. This is the waiting time. Okay, so this waiting time represents the cost to the ship owners and is a source of customer dissatisfaction with the docking facilities. As I already said, if you have to wait for a long time in the quay, obviously you are dissatisfied. So same thing happens for the ship owners also. If they have to wait for a long time in the quay, they will try to avoid that harbor. So whenever we try to tackle this real life problem, we will try to reduce this waiting time. Okay, so this is one of the factors. Actually what let me just specify here what we are doing here. We have discussed a specific example, then we are just summarizing whatever the details are coming from that specific example, then we will try to simulate the in general, not the specific example only, in general a harbor system problem via some computer algorithm, and then as we are trying to consider this one via Monte Carlo simulation algorithm will be our focus. So that means we will depend on random number generation. Okay, so that algorithm is to be given here, and other than that algorithm, what we are just focusing in the various factors which ultimately are taken into account once we generate the algorithm. Okay, so that means, say suppose we generate one algorithm and then we generate a data set using that algorithm. Again someone generates another algorithm with some other restriction, suppose, and then generate another data set. So all these data sets needs to be compared so as to meet up the real life requirements. That means this harbor problem. And when we are considering the harbor problem means what? You have to see the business options of the dock facilities, that means the harbors facilities, and also the business option of the ship owners. So in all those factors, obviously it is not up to our syllabus, we are not going to that details here, but the main thing is that whenever any algorithm is try to generate, we have to keep all those factors in our mind, so that one after another data set, if we just take from the original system and we simulate on our own via the computer program, we will try to compare them as usual. So that is when we are trying to compare as usual, then means what? Different data sets will come from where? When we put different situations, or when we put different restrictions, and these restrictions how we are getting this, all this depend on the various factors corresponding to the real life problem we are dealing with. And so some of the factors are discussed here. Okay, though we will, whenever we will just see the Monte Carlo algorithm, okay, we will take the standard which has been mentioned at the very beginning. Okay, Achha. Now, so this is the what they say, the waiting time. So obviously the ship owner will try to reduce the waiting time. Okay, on the other hand, the docking facility has only 25 minutes of idle time, so it is very good for them. They are not sitting idle, so obviously they are busy almost all the time, so they are making the most of it for the business workers. Okay, it is in use in 315 minutes out of total 340 minutes in the simulation, or approximately 93% of the time. So it is a huge one. Okay. Suppose the owners of the docking facilities are concerned with the quality of service they are providing and want various management alternatives to be evaluated whether to determine whether improvement on service justifies the added cost. As I already said, several statistics will help in just taking control or taking care of all these factors. We are not going into all these things because just they are giving some discussion, they are just putting some discussion in support of the fact that whenever we, as I already said, whenever we are just trying to simulate anything, we should be taking care of all the real life practical problems which can arise. Okay, so let us straight go into the algorithm now. So here it comes. So the summary of the harbor system algorithm terms. So these are actually the terms which are to be used in the algorithm. Okay, so what are the terms? These are actually the symbols. Let me just say between suffix I. As the name suggests, here the terms are given suitably, the names of the terms are given suitably, so that you can have the idea where it is used. Suppose you could have given xi, no matter, yi, again no matter, but actually we are given between I, so as to make this more meaningful. One who tries to read the program, he or she can understand it more comfortably. Okay, so between I, what the name suggests, between I means it will try to measure the time gap between the arrival of the ships. So see, time between successive arrivals of ships I here, so say ship I is here, and then before it I minus 1 has arrived, so what is the time gap in between? So that is between I. Okay, this between I, as I already said, the real life situation we have to cover the restriction. So what was the situation given? It should be between 15 and 145 minutes. Okay, so this between I is any positive number, that means z plus, and bounded between 15 and 145. Okay, less than or equal to, and like this. Okay, between 115 and 145 it should lie. Then arrive I, again the name suggests कि it should be the arrival time of any ship, ith ship. So between I was a comparison between there is a gap between two ships, so I minus 1 I was taken, but arrive I is only ship I is to be considered. So time from start of clock at t equal to 0, as I already said, key from t equal to 0 you are measuring everything. Okay, when ship I arrives at the harbor for unloading, so this is arrive I, ith ship is arriving at the time arrive I, like that. Unload I, then again amount of time taken by ship I to unload. Okay, now again there is a restriction here, as was imposed at the very beginning, कि it should be a random integer varying between 45 and 90 minutes. So two restrictions were given at the very beginning. One was the arrival time, the time gap in between two successive arrivals. It should not be less than 15 minutes. It will not be greater than 145 minutes. So this is here. Next is the unloading time. It should not be less than 45 minutes and it should not be greater than 90 minutes. So this is the restriction we have to keep in mind while we try to simulate the algorithm. Okay. Start I, time from start of clock at which ship I commences its unloading. Ideal I, time for which dock facilities are idle immediately before commencement of unloading ship I. Okay, so this is something related to the harbor system. Idle life. Acha, wait I, time the ship I waits in the harbor after arrival before unloading commences. So this is the idle time for the ship I, and this is the idle time for the harbor. Idle I and wait I. Okay. Acha, finish I, time from start of clock, that means t equal to 0, at which service for ship I is completed at the unloading facilities. Okay. Acha, then harbor I, total time the ship I spends in the harbor. Okay, this is a very crucial, as we have just seen before. How much time it is spending, obviously the business owner will try to minimize this time. Okay, and hard time means harbor time, average time per ship in the harbor. Max har means maximum time of a ship in the harbor. Wait time, okay, is the average waiting time per ship before unloading. That means the ship has to wait for this time average. Okay, and max wait means maximum waiting time of a ship, and idle time means percentage of total simulation time unloading facilities are idle. Okay, so you see all these quantities can be derived once we give some data. So this will be the outputs of the simulation algorithm. Okay, Achha, and average time you see here, whenever we have seen before in the table also, obviously the time spent per ship for any ship in the harbor is different for ship 1, different for ship 2, different for ship 3, likewise as was given in the table. But here if we take the total and then find out the average, then obviously it's, on average it is same for the all the ships. Like that we are calculating hard time and this wait time also, as we just showed above in this before this table, in the last one, this one. This is the wait time. Okay, this is the time in harbor, and then as we said ki these two we are calculating, these are not directly given the data set, these are the derivatives of the data set, that means these are calculated. Okay, the total wait as and when required, wait time was required to max wait time, so this was calculated 130, and then what is calculated, this average time was calculated, and then what was calculated, the time in the harbor is calculated, the hard time is this one, this is calculated, and then what else was calculated, 130 was already coming for the total time in harbor, like that. Okay, so now with all the terms set in, these are the terms to be used in the algorithm. Actually this much will be used to generate the algorithm, and this much will be used for the output part, for controlling the output part. Okay, so the harbor system goes like this. Okay, input, what will be the input? Total number of ships. So I consider n, small n, as a ships, number of ships. So n number of ships are arriving in a single harbor. Okay, acha, output, hard time, max har, wait time, max wait, and idle time. So as we said, if you want to just optimize all the business purposes and everything, we have to take care of all these factors. So those factors are the output of the algorithm. And another thing, this n ships are arriving in the harbor, and what is the characterization of the harbor? One ship is attended at one time, so it need not be the only possibility for any harbor. In many harbor, more than one ships, in fact in one of the most of the harbors, more than one ship are attended at a time. But here we are considering in the most simplest case, that's why we are considering ki at a time one ship is attended. So that is also there, but that is the qualitative aspect, right? So that is not coming directly inside this input part, but once we just try to go through the logic flow, that should be kept in mind ki only one ship will be treated at one time. Okay, and just step 1, randomly generate between between 1 and unload 1. 1 means ship 1. Acha, unload 1 means amount of time taken by ship 1, and between 1, how should we calculate? Because before ship 1 there was no ship arriving, so actually it is considered as the t equals to time when it is arriving, starting from t equal to 0. That is when the harbor is opening and when the first ship is arriving. That time is considered to be the between 1, particularly this one, because this is a bit, you may feel it is a bit how confusing how to calculate it, because ship 1 was the first one which is arriving. Then how should we calculate the gap of arrival between the two ships? Because if I equals to 1, then I minus 1 is 0. Then what should be this 0? Ship. Now no ship is there. Actually we are considering ki when the harbor is opening to give its facilities, that is considered as the starting time t equal to 0. Okay. Achha. So what I will first do, we will randomly generate two quantities, between one and unload one. That means two positive integers, because this is also time, this is also time. As I already said, throughout this whole simulation algorithm we will be simulating random numbers, but the random numbers nature will be z plus. That means positive integers only, because they are calculating or they are measuring times. So that definitely there should be z plus. Okay, so generating between one and unload one. Then once we generate and get some number, obviously, then what we do, we set arrive 1 equal to between 1. See, why arrive 1 equal to between 1? Quite obvious. Harbor is opening at t equal to 0. First ship is coming at t equals to, say, between 1. Okay, so as soon as it arrives, or when it is arriving at between 1 only, because between 1 is the time you are taking from t equal to 0 right to when the first ship is arriving. Okay, first ship arriving. Okay, so obviously this is equals to arrive 1. That means when the first ship is arriving is equals to between 1. Okay, acha. And unload 1 will be as will be given for the that can be anything. Okay, unload 1. Acha. Then for unload 1 that can be anything, but one thing should be kept in mind, that should not be less than 45 minutes and should not be greater than 90 minutes, because unload I was like that given in the real life situation. Okay, so that should be taken care of. Okay, acha. Now initialize all the output values. So obviously what we do, for first of all we set the variables, and then we declare the variables, and then we set some initial values. Okay, so all this hard time, XR, wait time, X wait and idle time, these were all the 5 outputs. We all this initialize. How we are initializing? Hard time, this harbor time is taken to be the unload 1. Okay, max R is taken to be unload 1. That means hard time was what average time spent in the harbor. So until and unless we get data or we generate data for the further ships, we consider whatever we are getting from the ship 1. So we are using the ship 1's data to initialize. That's what we are doing. Hard time we are setting to be unload 1. That means time required by the ship 1 to unload. Max R is then again unload 1, because only 1 is available, so maximum will be that one only. So unload 1. Acha, wait time equal to 0, because the ship 1 has not to wait, did not wait at all. It came and unloaded, so wait time equal to 0. So maximum wait time is average wait time, as only one ship is there, so average wait time is equals to maximum wait time equals to 0, because the ship 1 is not at all waiting. Idle time, arrive 1. Why? Idle time is what? The harbor time, harbor idle time. The harbor was sitting idle before the ship 1 arrived. So ship 1 arrived at t equals to arrive 1. So for that amount of time it was sitting idle. So idle time is arrive 1. Okay. So all these initializations are justified. See, whenever you are setting initial values, you may put any values. But for our logic flow, we should initialize in such a way so that we can use it for our purpose, right? So here is how we are justifying how we are taking these initial values. Okay, each of them is justified in this way. Achha. Then you come to step 3. Calculate finish time for unloading of ship 1. Finish time for unloading. What will be the finish time for unloading? Arriving time and unloading time. So t equals to arrive 1 plus t equals to unload 1 will be finish 1. So this is what they are calculating. So the whole ship 1 part is done. Okay. Now the remaining, that means from ship 2 up to ship n, up to ship n, we have to repeat the steps. What are the steps? For I up to 2 to n, steps 5 to 16 are to be repeated. What is step 5? Again we have to generate random number. Again we have to generate some random numbers z plus, that means corresponding to time. What are the random numbers? 1 for the successive arrival of ship I, that is between I we have to generate, and unload I have to generate. These two random numbers we need. So we are generating a pair of integers. Actually I should prefer you mention positive integers, because time cannot be negative. So if you mention only integers, that is not at all correct, because one may generate negative integer also. Okay, so please mention positive integers between I and unload I, and over the respective time intervals. Okay, so between I should not be crossing the limit of 15 to 130, 15 to 145, and unload I should not be crossing the limit between 45 to 90. So the random numbers which we generate should be belonging to the interval 15 to 145 for between I and 45 to 90 for unload I. So between I, random number should be anything chosen randomly, and again random number generation you can use the two procedures we have just learned. So between I should lie between this thing, and unload I between this one. Okay, Achha, so once that is done, then we will use this between I and unload I repeatedly. Let us see how we will use it. So let us go into step 6. Assuming the time clock begins at t equal to 0 minute, that means when the harbor is opening. Okay, calculate the time of arrival for ship I. So arrival time for ship I means what? Arrival time, as we have seen in the 5 ship experiments, arrival time of I minus 1 plus between I. That is what we did. For ship 2, what we did? At ship 1 is arriving at t equals to 20, and then ship 2 is arriving, say, after a gap of 30 minutes. That means if gap is 30 minutes, that means it is arriving at 20 plus 30, that is 50 minutes. So it is arriving at t equals to 50. That means how we are calculating it? We are considering the arrival time of ship 2 when we are saying. So we are considering the arrival time of ship 1. That means arrive I minus 1 plus the time gap between the two. Here gap between the two for my example is between ship 2 and ship 1. That means between 1. If we say we are calculating for arrive 2. Similarly for arrive 3 it will be arrive 2 plus arrive between 3, like that. So each and every step this will be repeated. Okay, so now calculate the time difference between the arrival of ship I and the finish time for unloading the previous ship I minus 1. That is time difference. Arrive I when it is arriving, and when the previous ship has stopped unloading, that is has finished unloading. Why we are just measuring it? Because see, this will indicate many things. First of all, it will indicate whether the ship which has come has to wait for some time, or directly when it comes it starts unloading. One. Second, if it has to wait, then how much time it has to wait. Third, if it has not to wait, it is coming and unloading, then obviously the harbor was sitting idle, then what is that amount of time? Okay, so time difference needs to be calculated as arrive I, that means ith ship is arriving, minus finish I minus 1, that means I minus 1 ship has finished unloading. Okay, if you recall back the last part of the lecture, you will just see we have calculated from the table just like this. When the ship 2 is arriving, when the ship 1 has finished unloading, then only I can make out whether the ship 2 was waiting in the quay or not. In fact, the ship 2 was waiting in the quay for some time. Okay, remember that 75 and 50 thing? So like that we are doing here. Okay, so now depending on this time difference, as I said, there will be an if-else sort of situation. So for negative time difference, that means what? Negative time difference means arrive I minus finish I less than 0. So arrive I less than finish I minus 1. That means this is the ideal time for the harbor. Okay, it is the ideal time of the harbor because arrive I am writing in short, less than f I minus 1 finish I minus 1. That means what? Here if I put less than 0, then I am getting this one. That means for that part of the system, but here they are saying something. Let me just see it once. Acha. So here the time difference, if it is non-negative, that means either 0 or positive, then what will happen? Here just I have given the wrong sign. It is just the opposite. So ai minus fi minus 1 is greater than 0. That means ai is greater than this one. That means arrival time, say suppose arrival time is t equals to 70 and the previous ship has finished as t equal to 60. So for the gap between 70 and 60, there was no ship to be attended. That means for 10 minutes the harbor was sitting until, right? So this will be calculated, and that means it will give the idle time for the harbor. So idle I equals to time difference, and wait I equals to 0, because the ship just coming after that the ship I need not wait, it comes and it unloads. Okay, so idle I will be time difference and wait I will be 0. Just the opposite will happen. If it is negative, this one is negative, then wait time is minus of time difference and idle time is 0. That means the harbor is not at all sitting idle, but the ship has to wait for the time, and as it is negative and the time, it should be time, so definitely I have to take the minus of it. That means we are concerned about the magnitude, obviously. Okay, so wait I equals to minus time difference. Now calculate the start time for unloading ship I. So when it will start, when the ship I minus 1 has stopped, then only it will start. That means at, say suppose at t equals to arrive I, it is arriving, and then it has to wait for some time, so wait I. So if I add these two up, say, then only t equals to, say for t1 it has arrived, but it has to wait for time t2. So t equal to t1 plus t2 is the time when it will start unloading. So that means arrive I plus wait I. And then the finish time for unloading ship I, start I when it has started plus amount of time taken for unloading. So start I plus unload I, so that will give you finish I. Okay, and the total time it has spent in the harbor waiting for some time and then unloading. Addition of these two should give the total time spent in the harbor for ship I. So that is what this is they are doing here. Okay, so now sum harbor I into total harbor time, hard time for averaging. Okay, so you are calculating for each ship. Now you just add up them all, so you get a total hard time. Now total time you are getting, and then you just divide by total number of ships. Okay, so as to get the average time spent per ship. Okay, Achha, now if harbor I is greater than maxr, what was maxr? Maxr was initialized corresponding to the data of ship 1, because at that time there was no data available. Okay, so maxr was unload 1, amount of time the ship 1 is taking in the harbor. Because ship 1 has not at all waited, so amount of time which is unloading is equal to the amount of time which is waiting in the harbor. So maxr was taken to be unload 1 there. So there now, if any other ship is taking more than that time, then I should take maxr as that ship harbor I. Say suppose ship 3 is taking more than the unload 1. Suppose unload 1 was 30 minutes, ship 3 is taking 50 minutes. So I will take maxr to be 50 minutes. So I will set maxr equal to harbor I. If not, that means all the ships are taking less than that amount of time. So maximum harbor time is that equal to the time given or the ship 1 is taking for unloading. So that means if you get something greater, you take that one for the maxr, otherwise leave as it is. That means leave whatever we have taken as the initial one here. Okay, so that one part is done, so one item is calculated. Now sum wait I into total wait time for averaging. Okay, so wait time was initially 0, now wait time is changing. What I am doing, whatever the wait I we have calculated for each I, okay, this one either 0 or something positive you are getting, then you just add them up for all the ships. Okay, so as to find out the wait time for averaging. Achha, wait time was what? How did it define the capital wait time? Yes, average wait time for ship before unloading. Okay, so that means suppose we have added up all the things. So suppose I got 50 and we are using 10 ships, so 5 minutes per ship for the wait time it will get. Okay, Achha, then sum idle I into total idle time, because it is for the harbor, nothing to here to average. Okay, so here total thing will be the total idle time. Okay, Achha, now wait I. See, if wait I, that is the ship I is waiting for this amount of time wait I. If it is greater than max wait, what was max wait? Initially it was again depending on the ship 1 itself, but ship 1 didn't wait at all, so max wait was 0. So now if you are getting for any ship I, obviously you will get this thing, it is waiting for some time, then which one is the greatest, you have to put it here. So suppose I give So suppose after ship 1 ship 2 is arriving, so at I equal to 2 you are getting this wait 2 to be say 20 minutes. Okay, so 20 minutes is greater than max wait, which was initially 0. So I will take max wait equal to, I am writing mw in short, equal to 20. Now we will consider ship 3. Suppose that means for I equal to 3 we will consider. Suppose for I equal to 3, the wait 3 is 40 minutes. So again it is greater than this one. Then mw will again be updated. It will be mw equals to 40. And likewise it will go on. Okay. And then, so max wait is said to be the wait by the largest ship waiting time you are getting, will that said to be max wait. Otherwise leave max wait as it is. Okay. So whenever you are getting this key, it is not further updated. So suppose ship 3 has 40 minutes, it is waiting time. And after that ship 4 is taking 30 minutes, ship 5 is taking 20 minutes. So lesser than that or equal to that, then we will keep this one as the largest one, maximum time. Okay. Then set hard time, as I said, ki average. So whatever hard time you has calculated here, you just take hard time by n. Wait time equals to wait time by n, and idle time equals to idle time by finish n. Finish n means total time you are taking. That is throughout the entire working hours of the dock facility, how much time it was sitting idle. That's why finish n is taken, because finish n is giving the last time. Total time t equals to what time you are taking. Suppose in the 5 ship problem it was 340, I guess. 340 minutes was the total time for the 5th ship. So up to the 5th ship, the last ship was unloaded, the harbor was fully acting. Okay, so for the full activation period, how much time it was sitting idle, like that. That's why finish n is taken. There is a last ship is to be considered here, total time for that, how much it takes for unloading. And finish I, you see, finish I, how did we do? Starting time plus unloading time. And again starting time is arriving time plus waiting time. So arriving time plus waiting time plus unloading time is the finish I. So for if I take the last ship, then definitely you are considering the whole time interval starting from ship 1 up to ship 5, if I consider the 5 ship example. Okay. So that means the whole time you are taking. So idle time for the harbor comes out to be idle time by finish n. And then output this all these quantities which you have calculated, and then you just say stop. So this ends up the algorithm, because these were the requirements to be generated and we have generated here. And next we will see, we will just discuss a few examples given from some of the tables, so as to see how these are used to just just observe or justify or other compare different data sets. Okay, so let's just stop here.